Welcome to the DIY Honda Garage channel. The DTC P0010 indicates a malfunction in the variable timing control, VTC oil control solenoid valve A, which plays a critical role in controlling the variable valve timing in Honda CRV models from 2017 to 2022. This solenoid is responsible for regulating oil flow to the VTC system, allowing for optimal engine performance and efficiency. It's typically found near the engine's timing chain or belt, making it integral to the engine's variable timing mechanism. When this solenoid malfunctions, it can lead to a variety of engine performance issues, including rough idling or decreased fuel efficiency. Understanding how this solenoid functions and its location is essential for effective troubleshooting. In the following slides, we will delve deeper into the description of the error, possible causes, symptoms, and step-by-step troubleshooting processes outlined in the diagnostic information. DTC P0010 refers to a malfunction of the VTC oil control solenoid valve A. This valve is integral in regulating the hydraulic oil flow that influences the engine's valve timing, which optimizes performance and fuel efficiency. When engine conditions require variable valve timing adjustments, this solenoid allows the appropriate amount of oil to reach the VTC mechanism. Typically, you can find this component near the engine's timing chain or belt, as it has to interact closely with the engine's camshaft operation. If it fails, various engine operations may be compromised, indicating the urgency of diagnosing the specific issues that arise from this DTC. Therefore, thoroughly inspecting this solenoid and its connections become a focal point in troubleshooting the performance of your vehicle. Several potential causes can lead to the DTC P0010 being triggered. First, there may be an internal failure within the VTC oil control solenoid itself, which can occur from wear, corrosion, or manufacturing defects. Secondly, poor electrical connections, including corroded or loose wiring at the solenoid or the powertrain control module, PCM, could disrupt communication and functionality. Additionally, issues with the PCM itself can also lead to this DTC being indicated, as the PCM is responsible for interpreting data from various sensors and controlling engine performance. Finally, external factors such as oil quality can influence solenoid performance. Recognizing these potential causes is critical for efficient troubleshooting and rectifying the issues related to this DTC. The symptoms associated with DTC P0010 can manifest in several ways. One common symptom is a rough engine idle, which can indicate that the engine is not running smoothly due to improper valve timing. Drivers may also experience poor acceleration performance, making it difficult to gain speed efficiently. Additionally, the check engine light on the dashboard will be illuminated, signaling to the driver that an issue has been detected which needs attention. These symptoms not only affect drivability, but could also lead to further engine damage if not addressed promptly. Knowing these symptoms enables car owners to take timely action to prevent more serious mechanical failures. The first troubleshooting step for DTC P0010 begins with turning the vehicle to the on position and ensuring that all electrical components are powered. Following this, the diagnostic trouble code, DTC, should be cleared using the Honda Diagnostics System, HDS. This step is essential as it resets the system and allows for fresh diagnostics. After clearing the DTC, the engine should be started and held at 3,000 RPM without load until the radiator fan activates. Then let it idle. This process helps in checking the operational state of the engine and any immediate issues that might arise post-clearance. It's crucial to observe whether the DTC reappears during this phase, as it will guide the subsequent steps in the troubleshooting process. Step 2 in troubleshooting involves checking the internal resistance of the VTC Oil Control Solenoid Valve A. Begin by turning the vehicle off to ensure safety during the inspection. Next, disconnect the solenoid's 2P connector to isolate the component for testing. With the connector disconnected, you will need to measure the electrical resistance between test points on the solenoid using a multimeter. The expected resistance value should fall between 6.77 and 8.27 ohms at room temperature. If the resistance is within this specified range, it indicates that the solenoid is functioning properly, and you can proceed to the next step in troubleshooting. If not, replacing the VTC Oil Control Solenoid Valve A becomes necessary, as it may be defective. Step 3 focuses on checking for continuity in the power ground PG line to ensure proper electrical flow. With the vehicle still in the off mode, you will check for continuity between the designated test points, the VTC Oil Control Solenoid Valve A's 2P connector, and a solid body ground. This step is fundamental because a lack of continuity can indicate an open circuit that would prevent the solenoid from properly functioning. If the continuity test reveals a clear connection, then the PG wire is intact and functional, allowing you to move on to the next troubleshooting action. However, if there is no continuity, you will need to locate and repair the open circuit in the PG wire running between the VTC Oil Control Solenoid Valve A and ground point G101. In Step 4, you will check for a short in the VTC in wire, which is also crucial to the solenoid's operation. Begin by jumping the SCS line using the HDS for more than 1 minute, which allows adaptation in the diagnostic mode. Then, disconnect the PCM connector E to ensure no interference while testing. Following these preparations, a continuity check needs to be performed between the connector of the VTC Oil Control Solenoid Valve A and a body ground. If the test indicates that there is continuity, it means there is a short somewhere in the VTC in wire that you will need to repair. If no continuity is found, you may proceed to the next troubleshooting step. The final troubleshooting step involves another continuity check, this time on the VTC in line. Ensure that the vehicle remains off and that both the VTC Oil Control Solenoid Valve A's connector and PCM connector E are disconnected. You will check continuity between the first female terminal of the solenoid's connector and terminal number 64 of the PCM. A successful continuity test indicates that the VTC in wire is functioning as required, and you can look into service information related to DTC troubleshooting or substitute a known good PCM if issues persist. Conversely, if continuity is absent, there is an open wire in the VTC in circuit that must be rectified to restore proper operation. Once all repairs have been conducted related to DTC P0010, final verification is crucial to confirm that the issue has indeed been resolved. Start by clearing the diagnostic trouble code using the HDS, which refreshes the system for new diagnostics. Following this, a test drive of the vehicle is imperative to ensure that it operates correctly under various conditions, particularly paying attention to engine performance, idling smoothness, and response during acceleration. During the test drive, monitor for the recurrence of the check engine light and any abnormal symptoms that may arise. If the DTC remains elusive after driving and the engine runs smoothly, it indicates successful repair. However, if the DTC reappears, further investigation will be needed to ascertain the problem's root cause. Preventive maintenance plays an essential role in reducing the likelihood of encountering DTC P0010. Regular oil changes are crucial, as dirty or degraded engine oil can affect the oil control solenoid's performance. The quality of oil also influences the solenoid's ability to operate effectively. Therefore, using the recommended oil type is advised. Additionally, routinely inspecting wiring connections related to the VTC oil control solenoid can prevent issues caused by corrosion, fraying, or disconnections. Evaluating the overall condition of the VTC components, including the solenoid itself, can help identify early signs of wear or malfunction, allowing for timely reparative actions. Taking these preventive steps can prolong the lifespan of your engine components and enhance driving performance. In summary, the DTC P0010 indicates a malfunction in the VTC oil control solenoid valve A, which plays a pivotal role in the optimal functioning of the engine's variable valve timing. Understanding how this solenoid operates and its importance can lead to faster problem identification. Following a systematic troubleshooting approach allows for effective diagnosis and resolution of the underlying issues. It is equally important to remember the significance of regular maintenance practices, such as timely oil changes and periodic inspections, that can preemptively mitigate problems related to this DTC. Awareness and education surrounding the components associated with DTC P0010 will aid vehicle owners in maintaining their Honda CRV in top-performing condition, while also enhancing overall longevity and performance. Please like and subscribe to the channel. See you next time.